Welcome again to a new Ambura tutorial. Many years ago, I wrote a couple of publications related to signal cloning from radio and infrared devices. Even though it was a great achievement for me back then, now I see that there is still so much work to be accomplished and enhanced. So I decided to resume this job and give the final touch, at least for now. I will embark on this new cloning series, in which I will be enhancing this previous work of mine, improving the way signals are captured in order to make the process of cloning a set of signals more practical. Also refining the code to prepare it to assemble it with a client interface on the computer side to control the cloning and emitting. We will start with infrared cloning. I suggest you go and review this work so you can get a grasp on what I'm trying to accomplish. In short, the idea behind this is to make it super easy to clone as many signals as you want and test them right away. As you may know, remote control devices using infrared signaling use different protocols to structure the signaling depending on the brand, maybe also on the type of device. But at the end, it all goes down to a combination of timings that a LED is turned on and turned off during a period of time, basically in microseconds. Based on this, we will use the core Arduino function attach interrupt to link a function to a specific pin input, the infrared receptor, that will be storing the time in microseconds between changes of this pin state on and off in the array. The attach interrupt function basically hardwires the pin input to a certain logic, making it suitable for things that happen in an ultra-fast fashion. You will find a link in the description to an explanation of this function. Then, once we have stored the signals, we will print it as a sequence of numbers separated by a comma and finalize it by an ampersand symbol, marking the end of a signal. That sequence, we will be able to copy it and send it to test it if it works. So let's see the code. First thing first, you will see that I updated the code so that it contains both cloning and emitting functions. You will be able to clone and test it right away. For that, you have in the loop function the code that reads the serial, expecting the characters 1 or 2 for clone and emit respectively. The cloning function will clear the signal storing array and set the attach interrupt with a very simple function that stores the timeouts, followed by a while loop that will be looping until a stop signal is incoming, represented as a pipe character. This basically is in case you want to halt the process, or until signal's pointer variable is greater than 0, which means that the signal is incoming. We wait until the signal is completed. This number may vary, but so far is enough. We detach the function preventing any other casual interrupt and simply print the array as we explained it earlier. On the other side, the command represented by the character 2 will ignite two functions. First, the reading of the signal from the serial. So basically, Arduino will wait until you paste the signal cloned previously. Yes, this is kind of tedious, but we will solve this problem very soon. For now, it will suit us just fine for testing purposes. As you can see, this function reads signal from serial is kind of large, but it has no mystery. Simply reads each character, joins the number as 1 after each comma with the help of the utility array one signal, and detects signals ending and the stop action explained before. Notice at the beginning of each action we clear the array with the function memset for starting over. The second function, send signal, will be looping the signal array which will execute each pulse by turning on and off or wait sequentially for each signal. So basically you see that the signal represents interleaves periods of pausing and waiting. Two things to point out here. First, you will see the use of memory-free library. Basically, this is for checking that the memory of our Arduino is not overflowing. You can remove this library and its related lines if you want. Since we are using a large array, I found it handy to check the Arduino memory frequently. Second, you see the printing of different strings like waiting for signal in uppercase. We will use those not only to see that the commands are being executed correctly, we use them to implement a client interface on the computer side to handle all the processes and store the signals as well. Bear in mind, this will remove the necessity of copying and pasting signals, which, by the way, I find very annoying. I will present this interface in the next tutorial. Finally, you will see that I am testing this with a shield that I made basically to make it easy to plug and unplug the receptor and emitters from both radio and infrared. As you can see, it's not very neat. I found it very hard to solder all the little cables and sockets, but finally it served its purpose extremely well. In your case, you can simply connect the different boards, radio and infrareds, as explained in the original cloning publications. Let's see how it works. Thank you very much, see you in the next one, and have a good one.